All right, let's journey about 27,000 light-years away, out to the constellation Capricornus. We're heading to a place that honestly shouldn't even exist, an ancient, collapsed star cluster called Messier 30. This thing is a relic from the dawn of time. And you know what? It's breaking all the rules of astrophysics. So let's dive in and find out why.
Just look at this. This is the heart of Messier 30, a city of hundreds of thousands of stars, all crammed into a space that's just impossibly small. For billions of years, this place has been evolving, creating things that really push our understanding of how stars work. So the big question for us today is, what secrets are actually hiding in that crazy dense core?
Okay, so to really get why M30 is so weird, we first need a quick primer on what a normal globular cluster is supposed to look like.
So think of a globular cluster as a giant, self-contained city made of stars. They're these huge spherical collections of really old stars, some of the oldest things in our galaxy, in fact. And they orbit the center of the Milky Way, kind of like their own little satellite galaxies.
Now, the textbook version of these clusters is that they've got hundreds of thousands of stars, all born at the exact same time, from the same cloud of gas. For a long time, astronomers called them simple stellar populations because, well, it seems simple. All the stars should have the same age, the same chemistry, a nice, tidy picture. But as you're about to see, M30 just throws that whole idea out the window.
All right, let's get to our main subject, Messier 30. This is a globular cluster that takes absolutely everything to the extreme.
First off, just look at its age. We're talking an estimated 13 billion years old. That is almost as old as the universe itself. It's a true relic that has seen nearly the entire history of our galaxy unfold.
And over those 13 billion years, gravity has been doing some wild things. M30 is what we call a core collapsed cluster. It's a process where the heaviest, most massive stars slowly sink towards the center, pulled by their own gravity, creating a core with a density that is just almost impossible to imagine. So here's the key takeaway. M30's core is one of the most chaotic and crowded places in the entire galaxy. And all that intense gravitational squeezing, well, it creates the perfect laboratory for cooking up bizarre and exotic types of stars that you just don't find anywhere else.
And this brings us to the central challenge for astronomers. See, we know this crazy environment has to be making a hidden population of stellar oddballs, but trying to actually find them in that dense core is incredibly difficult.
So what are they looking for? A whole cast of characters called stellar exotica. You've got blue stragglers, stars that look way too young to be in such an old cluster. They were probably formed from stars colliding and merging. Then you have white dwarfs, to super dense corpses of dead stars. And my favorite, cataclysmic variables, actual vampire star systems, where a white dwarf is literally sucking material off its partner star.
But here's the problem. When you look at M30 in normal, visible light, it is just a mess. You see all those yellow triangles? Those are just normal, everyday stars. The really interesting ones we're looking for, the green circles, are completely lost in the crowd. They're too faint, and there's just way too much glare from everything else.
So this poses a huge question, right? With thousands of stars all shining at once, how in the world can you peer through all that glare to actually find and study the cluster's most fascinating residents?
Well, the answer, it turns out, is to stop looking with our eyes or even with regular telescopes. Instead, we use a secret weapon, ultraviolet light.
And this just shows you the solution perfectly. On the left, that's M30 and standard UV light. Still pretty crowded, but look at the image on the right. That's the view in far-ultraviolet, or FUV light from the Hubble Space Telescope. Suddenly, the entire crowd just vanishes, and only a few bright, distinct objects are left.
So why does this work? It's because normal, cooler stars like our Sun are actually pretty dim in FUV light. But those hot, exotic objects, the blue stragglers, those vampire white dwarfs, they blaze like beacons at these wavelengths. It's exactly like putting on cosmic night vision goggles that filter out all the noise and let you see only the targets you're looking for. It's a game changer.
This new way of seeing totally transforms the data. So on the left, you've got that messy optical view again, but on the right, with the FUV data, boom! All the different populations, the main sequence, the blue stragglers, the white dwarfs, they just pop out into these clean, distinct groups. For the very first time, astronomers could clearly separate and study M30's hidden population.
So what did they find? Well, this powerful new data solves some really old mysteries. but it also uncovered brand new ones that are honestly even more puzzling.
First up, a big confirmation. This chart shows where different stars are relative to the cluster center. I want you to look at the blue dashed line. That represents the blue stragglers. See how steeply it rises towards the center? That's the smoking gun evidence they were looking for.
This proves it. The whole process of mass segregation, where heavy stars sink, is really happening in M30. The heavier blue stragglers have definitely fallen into the core, exactly like our theories of gravity predicted they would. So, case closed on that one.
But, science is never that simple, right? Previous studies in visible light had suggested that blue stragglers came in two distinct families. But when you look at them in UV light, those two families are totally mixed together. What's going on? Well, one theory is that some of them are those vampire stars actively feeding on their companions, which makes them glow in the UV and kind of messes up our neat little categories.
But the biggest mystery of all came from a different study. We now know that even in these ancient clusters, stars can form in different waves or generations. And in M30, researchers found something that was completely backward. The very first, oldest generation of stars were all clumped together in the center, the exact opposite of what we see in every other cluster we've ever looked at.
And this is why M30 is such a massive puzzle. The model on the left is what we expect to see. The oldest stars should be spread out. But the reality in M30, on the right, is that the very oldest stars are crowded into the core. It's fundamentally wrong, and we don't know why.
And really, that's what makes M30 so incredibly important. It's a perfect cosmic laboratory. On one hand, it beautifully confirms our big ideas about how gravity works in these dense environments. But on the other hand, it presents us with puzzles about star formation that we just have no answer for right now.
And that leaves us with this profound puzzle. We look to M30 expecting to find a simple fossil from the dawn of time. Instead, we found this dynamic, rule-breaking city of stars that challenges our most basic assumptions. The question isn't just what is happening inside M30, but why are its oldest stars sending us a message from across the eons that we don't yet understand? The answer is still out there, waiting for us, 27,000 light-years away.